No.
My guess is let cos theta be equal to A.
Okay. So 2 cos theta open brackets A.
Cos theta is A, and so cos squared
Oh, so
theta.
A squared. 2A
Yeah,
squared. Minus A.
yeah.
Minus 1 equals 0. I'm not sure where to go from
Calculator.
here. Yeah.
What type of equation is that?
Well, quadratic.
Yep.
Okay. So 2 times 1 is 2. So
Don't worry about that. What calculator? Equation. Polynomial. Degree 2. Do you have this
no,
one?
I don't have that one. I don't have that one.
I need to post one to you. Let me make a note.
Thank you.
Post 991EX. I just posted it. So which calculator do you have?
Casio FX83 GT.
That's the only one you have?
Yeah, I had the one that you had. I bought it before, but I lost it somewhere. So
Yeah, if I send you this, you'll probably lose it as well. Do you have a graphical calculator?
not too sure. I don't think so.
Send a graphical as well. Don't lose them or I'll lose you. Let's see. What is A? What is B? What is C?
2, 1 and 1.
Something's missing. It's not 1. It's close.
Minus 1. Sorry.
Minus 1. Minus 1. And you can do it by factorizing. So A is 1 or A is minus a half. Yeah, so A equals 1 or A equals minus a half. So you could factorize it and you could say, A plus 1 and 2A. Wait, is that equals 1? Sorry, A minus 1 and 2A plus 1 equals 0. So you could do it by factorizing. Okay, so A is 1, but we don't want A. We want theta.
So replace A by cos theta. So cos theta equals 1.
How do we do these?
Inverse cos of 1.
Yep.
So 0. And then inverse cos of a half. 60.
Okay. We can get more answers. The range is 0 to 360.
So it's cos. So do we have to add?
Cos theta is equal to cos 360 minus theta.
Okay. So 360 minus 60.
Yep.
Gives us 300.
And
then we did this. Well, we did this 360 minus 0 is just 360 again. So
yeah, and I don't think we'll be getting more than that. So, what are our answers for theta?
0, 60, 300, and 360. Do we have to do this every time? To get more answers?
Yep.
If possible. Okay.
Yeah, sure do. There are more solutions. Hold on. What is this? 0 and 360 is correct. Did you? Let me see this. I'm in radians. Shift setup. Angle unit degree is shift cos minus a half. How did you get 60? Did you plus a half, was it?
Oh yeah, I did.
Okay.
Wait, is minus a half? Oh yeah, it is. I didn't see the minus half. Okay.
Okay. So that one's 120. And so the other answer then?
240.
Yes. So that one's 120 and that is 240. Was that right? No. Which one was it? The 60 was the... So 0, 360, 120, 240. Great. Big picture, let the smallest one, the one that isn't squared, be equal to some dummy variable like a, and then unlet it once you've done what you need. It just makes it a bit easier.
Okay.
Right, let's do part A.
So tan x equals a. So a squared x minus 2a minus 4.
Okay. So a squared minus 2a minus 4. 0. Let's try factorizing it.
Sorry, is it not tan x? Oh, you wrote that. Sorry. Okay. So 5. So a in both brackets. Then not too sure.
Two numbers, multiply to make minus 4, add to make minus 2.
I can't think of anything because minus 2 would make positive 4.
Ah, you're right. So this one would be, I think you're supposed to use a quadratic formula.
Okay.
So, alright, we'll show our working out. So, A equals, so just sub in A squared minus AC. So sub in the stuff, what it would be.
So b is minus 2, so it's minus 2. Okay.
Yeah.
Then the root of 2 squared minus 2 squared. Okay. Minus 4 times 1 times minus 4.
Yeah.
Over 2, just 2. 2 in brackets 1.
Yeah, so that's our working out. And then I think I would just use the calculator to get the two values. So I wouldn't do that one. I would just do this instead. 1 minus 2 minus 4. And there we go. We get 1 plus or minus root 5. So A equals 1 plus or minus root 5. Is that full marks?
Okay. And so for b, do we do b?
Yeah, actually, so that is tan x. And then b, yeah.
So do we do inverse tan of 1 plus root 5 and 1 minus root 5?
Yeah.
I got an error.
For 1 plus root 5?
For 1 plus root 5, it's, yeah, oh, 72.82 now, so
72.83.
0.83.
Let's just do 72.8.
Okay.
Okay. What's next?
Minus 51.02. 02.
Minus 51 point, I'll go 0. Minus 51.0. Okay.
So from here, is it still 360? Minus
That's cos. Do you know the rule for tan?
tan, it's 180 plus.
Well done.
So 180 plus 72.8 is 252.8.
252.8.
Do I keep going until I get to 540?
Yep.
Okay. 432.8.
32.8.
I'm pretty sure above that, yeah, it's too high.
Right.
Then minus 51, so 180 plus minus 51 is 129.
Right.
78.
78.
Yeah.
What do you mean?
Keep going until we get to 0. Oh, sorry. I was minusing every time. Okay. So it's plus 180 still.
Yeah.
209.
209. Right.
309, sorry.
Yeah, 309.
No. 489.
89. That's probably it. And so, what are the answers for X?
72.8. 252.8. 432.8. 129, 309, 489.
Yep. And why not minus 51?
Because it's not in the boundary.
Well done. And so we got 3 for one and then 3 for the other. So it makes sense. Let's see. 72.8, 129, 252.8, 309, 432.8, and 489. There you go. So, yeah, let tan x be equal to a. Write it in terms of a. Solve, and I showed working out using the quadratic formula. Much easier to use the quadratic solver in the calculator rather than the formula in the calculator. But you proved it with the formula. And I believe this is necessary for the working out marks, the method marks. And then, yep, just the long solving from there. And let me just see something else. So we did a cosine one. We did a tangent one. Okay, let's see this one. This looks a bit different, but that's the same idea to me. Yeah. That's another... Alright. How about this one?
Did we do that in the beginning of the... I don't know, the equation looks similar, but...
It says it has no solutions. So how do you show that it has no solutions?
Cos x becomes a. Yeah, cos x.
Yeah.
So 2a squared plus a minus 6 equals 0. Then it's quadratic, so solving it would be 2 brackets.
They say there's no solutions.
they want us to make a equal to something, so put the numbers on one side.
Oh, let's see. So the thing in general is the quadratic formula. That's something that will always work. So even if it doesn't factorize, even if you can't complete the square or whatever, you can always use the quadratic formula. What part of the quadratic formula determines the number of solutions you get?
The root?
Yep. Yep.
Okay.
And what's in the root?
B squared minus 4ac.
Yep. And so b squared minus 4ac. What is that for this one?
Sorry?
So what is b squared minus 4ac for this equation?
1 squared
Mm-hmm.
minus 4 times 2 times minus 6.
Yeah. Minus 4.
So that gives you minus 8 plus 54. No, 72 of it.
Minus 14 times c b squared. Right. So 1 minus 48. Is that it?
Yeah, that's what it is, yeah.
So it turns out it's 49. That gives you plus or minus 7. What am I doing wrong there? Oh, that's very sneaky. That's very sneaky. We could have solved it. It would have factorized. Where is it? 2 cos x minus 3. This is something different from what I was expecting. Alright. Cos x plus 2. Alright, let's solve it.
So did you just yeah.
Yeah, just factorize. Yeah, sorry. I should write a. I did cos x. We'll just
Yeah, it's fine. Just how would you know whether it's this or what we did before?
well, I just did it this way. The discriminant, I was expecting the discriminant to be less than 0, and because that's one way to get no solutions, because you can't square root a negative.
Yeah.
But that worked. It was 49, which is like plus or minus 7. You know, so we would get solutions. So let's try. Because it's trig, let's just actually try to solve it.
So 2 cos x equals plus 3.
Mm-hmm.
Or cos x equals minus 2.
Mm-hmm.
So cos x equals a half or minus 2. 1.5 or minus 2.
Yeah, and so what is x?
The inverse cos of both these things.
Go on.
There's an error.
Why is there an error?
Because there's no solutions.
Yeah, why are there no solutions?
Minus 2 because it's a negative.
No. Cos
Is it
graph.
because it doesn't go 1.5 and minus 1.5?
Yeah. Cos goes up to 1 and down to minus 1. 1.5 and that one. Yeah. Cos x is between 1 and minus 1. Solutions are outside the range.
And sin x is also the same?
Outside range. Yeah, sin x, same thing.
But tan x, it goes on forever.
Yeah.
Okay.
Now that I was not expecting. Okay, so I was expecting the discriminant to be less than 0. It was actually that the solutions are outside the range. So I suppose just try to solve it. that's one way to do it. You just try to solve it, and if you can't, you'll know why.
Okay.
Find all the solutions to this one. So how would you start this one?
Sine x becomes, well, is equal to a.
Okay, but we have a mixture of sine and cos.
Oh. One, I'd make cos x 1 minus sine x.
Cos x isn't equal to 1 minus sine x. The identity is involving sine squared x and cos squared x.
Okay, so make sine squared x equal to 1 minus cos x.
Yeah. So it becomes 1 minus cos squared x. Okay.
Eight.
Mm-hmm.
8 plus minus cos 8 plus 8.
That's right,
8
minus.
plus, yeah, minus 8 cos squared x plus 6 cos x minus 9.
Mm-hmm.
Then let's cos x become a.
Mm-hmm.
So 8 minus 8 a squared plus 6a minus 9 equals 0, and then rearrange to get 8a squared minus 6a plus 1.
Well done. And then you just solve it from there.
Okay.
I think you'll be fine. And it says to 1 decimal place. How do you show you're working out?
Factorize and then use the quadratic formula.
Well, one or the other. It says to 1 decimal place, and so which one would you use?
Quadratic formula.
Yeah, if it's to 1 decimal place, then it doesn't factorize, because a factor has to be a whole number.
Okay.
Shut my mouth, it does factorize. I really need to figure these things out. So the reason why, because a factorizes. So a will have like whole number type of stuff, but cos doesn't. Alright. Both will work, factorize or quadratic formula. Alright, how do you start this one?
Um, 15 open brackets 1 minus cos squared x.
Mm-hmm.
Close brackets plus 8 cos x minus 16 equals 0.
Yeah, and then you're fine for the rest of that. It's all the same.
Okay.
I'm just checking the first bit. How would you start this one?
Make it equal to 0 first, so minus 7 sine x.
Right.
And then 2 open brackets 1 minus sine squared x.
Yeah, and then you just go from there. Oops, squared x. Okay, great. 3 cos squared x, that's very similar. So you have to bring it to the other side. Okay. How about this one?
same, make it equal to 0. So 2 cos squared x plus 9 sine x minus 3 sine squared x.
Okay.
Then make it equal to sine still. So 2 open brackets 1 minus sine squared x.
Oops. Yeah. Squared x plus 9 sine x minus 3 sine squared x equals 0. And I think you'll be fine for the rest of this. Yeah, this we had a mixture of sine and cos, and so you go with sine because 2 had sine and only 1 had cos.
Yep.
So it'll be quicker. And so how would you start this one?
Make it equal to 0 again. So minus sine squared theta. Then so get sine squared theta to become 1 minus cos squared theta.
Yeah, that'll work. And actually, I'm just noticing that 1 minus sine squared theta is already there, so that could just be swapped in. But you'll get the same result if you do it that normal way. It'll simplify to that. Yeah, great. So this time you change it into cos.
Sorry, just a question on the yeah. How did you get rid of that minus 1 there?
I just noticed that you like 1 minus sine squared theta. So I kind of skipped a step. You'll reach the same thing if you replace it. You'll have 1 minus 1. You know when you put it in.
Yeah.
Show that can be written like that. Okay, let's skip to part B. And we can use what they tell us in part A.
Okay. Sine squared x minus sine x plus 1 equals 0.
Say it again, sorry?
Sine squared x minus sine x plus 1 equals 0.
That's it. Sorry, I thought you said tan squared x. Yeah.
Then make sine x equal to a.
Yeah. So a squared minus a plus 1 equals 0.
Then, yep, so factorize to get same for this one. I don't see what I could use.
So let me try the solver. 1. Okay, so solver has given me imaginary numbers. So how would we solve it if we can't?
Quadratic formula.
So we'd use the quadratic. Okay, so sub.
Yeah.
Go for it.
B minus 1 in brackets, so minus 1 plus or minus root of minus 1 plus, I think,
squared.
Okay, squared, and then minus 4 AC, so 4 times 1 times 1 over 2 in brackets 1.
Yeah.
So that gives me 1 plus or minus 1 minus 4 in the root.
Yeah, plus or minus square root of 1 minus 4.
over 2.
Yeah.
Simplify it further than that.
How?
Just 1 minus 4 equals minus 3.
Yeah.
Then I can do it in my calculator.
Go on, put in to your calculator. What does it say?
It says an error.
Yep. Why is that?
Not too sure.
It's
because negative. Can't.
Yeah, so b squared minus 4ac is less than 0. Therefore,
There's no square root of a negative number.
and basically no solutions. Yeah, b squared is, you can't square out a negative. So there's no solution. So this time it was the discriminant, the b squared minus 4ac part. As b squared minus 4ac is less than 0, therefore there are no real roots. Yeah, so it seems like if you do try to solve these, you'll eventually just reach a roadblock anyway. So you don't really have to know. You'll just reach it if it's the discriminant or if it's, outside of the range of 1 or minus 1.
So solving as a quadratic is better.
I think you always have to solve it as a quadratic. Yeah, and you can always use the formula if you want. Let's see this one. Show it the equation. So how would you start? Yeah, how would you do part B? It's a bit different.
Make cos equal to 1 minus
No, let's
sine squared.
let's just skip to part B. They tell us that this can be written like this.
Okay.
And so how would you?
5 sine squared x equals 4.
Yeah.
Let's sine x be equal to a.
I don't think you'll need to for this one. It should be straightforward. So how would you solve it if you didn't let it be equal to a? Both will work.
Divide by 5.
Yep.
So 4 over 5 is 0.2.
And 0.8, is it? 1 over 5 is 0.2.
Yeah, 0.8. Don't know why I thought it was 0.2.
I think you're looking at this 1 here, but we've changed it into the equals 4.
Oh, okay. And then from there on, no, not yet. Square root both sides.
Yep.
So 0.8 square rooted is 2 root 5 over 5.
Okay.
And then inverse sine of 2 root 5 over 5 is 63.4.
So that's 63.4 degrees. Okay.
And then it's sine, so 180 minus 63.4.
Mm-hmm.
It's 116.6.
116.6. Is that all the solutions?
Do I keep going?
Well, it's between 0 and 360.
So 180 minus 116.6 would still work.
And so what's it?
180 minus 116.6 would still work.
That'll give you 63.4.
Yeah, so it worked.
Yep. So those are correct.
Okay, it's the same answer. Okay, so
x squared equals 9. What is x?
3.
Is there another answer?
Plus or minus 2.
Yeah. And so is there another answer for our one here?
Plus or minus 2 root 5 over 5.
Yeah. And so sine x is also equal to negative 2 root 5 over 5.
Okay. Oh, so... Yeah. 180 minus 2 root 5 over 5.
Arc sine first.
Yeah. Minus 63.4.
Okay.
$243.4. And that's pretty much it.
Minus 63 is not between 0 and 360.
$243.4 as well, so nothing changed.
Is what, sorry?
I did 180 minus 63.4.
Yeah, so 243.4 is fine.
Yeah.
But minus 63.4 isn't between 0 and 360.
So what do I have to do to get it between?
So of these 4, only 3 of them are valid. You can get a 4th solution using minus 63.4.
Do I add 360?
Correct. Well done.
Okay.
And you could add 360 to any of them, but they would be just outside the range then.
296.6.
296.6 degrees. Great. And so those are our 4 solutions. We would discard the other one. We wouldn't include that other one. 243.4, 296.6 degrees. They probably simplified those down, did they? No? Great. Yeah. So this type, it was a kind of a more straightforward way of solving it. You just divide both sides by 5 and then square root both sides. So you could have done the A thing and then changed it back, but you don't really need to. It was just kind of a straightforward type.
Okay.
So how would you start part B for this one?
Make it equal to 0, I'd say first.
Part A, they said show that can be written like this.
Oh, okay. So 3 divided by 4 is 3/4, then the root of 3/4.
What is the root of 3/4?
Root 3 over 2.
And so is sine x equal to root 3 over 2?
Plus or minus root 3 over 2.
Well done. And I write it the long way just because it's easier to actually, you do all these solutions for this one and then all these solutions for the negative one.
Okay.
And I think you'll find, the rest of that, you just whatever, arc sine both sides, that's not the difficult bit. The difficult bit is just the first bit, because it's just very long, getting all these solutions, and you're fine for those. This one wanted solutions between minus 180 and plus 180. I think actually that one will work out. Yeah, I think that one will work out. Let's see this one. Looks like it's the same idea, just a bit more work or something. No, Alright, how do we start this one?
Make it equal to 0 as well, I'd say. First.
Okay.
So 2 cos squared x plus sine squared x minus 10 over 9.
Okay.
And then from then make sine squared x 1 minus cos squared x.
Okay. What's next?
Just a question for would there have been easier? No, maybe not. Okay. Make everything a.
I think
so equal to a. Sorry.
I think you can avoid that. Let's say we simplify it first. What do you get?
Oh. 2, 3 minus 10 over 9. Oh no, sorry. Cos squared x plus 1 minus 10 over 9.
Yes. So cos squared x plus 1 minus 10 over 9 equals 0. Yeah.
Then minus 1 over 9.
Yeah.
Cos squared x minus 1 over 9. And then minus 1 over 9, make it equal to, put it on the other side, so plus 1 over 9 on both sides.
Yeah.
Then root it.
And what do you get?
1 over 3 plus or minus 1 over 3.
Well done. Cos x equals 1 over 3 or cos x equals negative a third, and then you just go from there. That won't be too bad. You just do arc cos for both of those and you get just 2 answers. Great. So that one, yeah, you had to do some work to get it like that, and you could always change it to a, but you'd just be changing it back. There'd just be one a, you know, it's not too much. Let me see this one. That one, yeah. This one's exactly the same. Numbers are a bit different. I think you're fine, personally.
Okay.
Okay, let's give this one a go.
Multiply out the brackets.
It's not times it, it's just the sign of it.
Oh. I'm not too sure.
This one, it would be easier to let it be equal to a.
Okay, so a. Just the whole thing equal to a?
Then it would just be a as a half. It's not really helpful.
No, so sine squared theta equals a.
Well, it isn't sine squared theta because it's. Let me think. So it'd be easier if we do theta minus 30. Yeah, you try to get rid of the difficult bit. That's kind of what you do with a. You just use it to remove the bit that makes it difficult.
Okay.
So
sine squared a equals a half.
So sine squared a equals half. Yep.
And then inverse of do roots both sides, sorry?
Say it again.
Root both sides?
Yeah.
To get root 2 over 2. Plus or minus root 2 over 2.
Well done. What's on the left
Then
side?
you, sine A.
Well done.
And then inverse of root 2 over 2.
Yeah.
$45.
Okay.
And minus 45.
Plus minus 45. We need to do something before we go any further. So the question just has a bit of a misprint. It says 0 is between, sorry, x is, sorry, it should be theta. Theta is between 0 and 360. What are we solving for?
Theta minus 30.
Yeah.
So it's between minus 30 and 330.
Yes. And so we got minus 45 and 45. All right. What's next?
But it's sine, so first of all, is it 180 minus 45?
Yeah.
And then 180 minus 45, which is plus 45. So 135
So that's 135.
and 225.
225. Okay.
Then from then on, minus 45 we add 360.
Minus 45. Yeah, very good.
215.
So that's 315. Okay. So we've got 45, 135, 225, and 315.
Yeah.
So that's what A is. But we invented A. Question never asked us for A. And so we need to swap it back. So what is A? They wanted theta.
Sorry?
So they asked for theta, but we did A.
Oh, so theta minus 30?
So theta minus 30 is equal to those 4. And so how do we get theta?
Minus 30 everywhere.
It's already minus 30 on the left side.
So 15.
No. Opposite of minus 30. Inverse.
Oh, okay. So 75.
Yeah.
165.
Yeah.
255. And 345.
3, 4, 5. Let's see. 75, 165, 255, 345. Yes. So this is similar to what we saw last time, except now they have squared with it as well. You let A be equal to the function inside the function, the bracket, fully solve as much as you can, and then you change it back, and it simplifies things a lot.
Okay.
It means you don't accidentally try to solve it. Okay, so equations and identities. What do you give yourself?
A tick for today. Yeah.
So I would like one more of this type of question. Solve for theta in the interval sine squared, and it's that one. This is pure. And this was 10.6. 10.6. Equations and identities, I think it's called. What do you want from me, bookie? .6. Oh, this is year 2. Year 1 pure. It's there. Yeah, now I'm seeing it. Equations and identities. I'll find it in a second. Let's see. So I want something squared. No, let's try other book. I suppose I could just make one up myself. Year 1 pure. Did that not work? 3.3. No. 10.6 E. Let's see. 5. I'll just make one up myself. Okay, hang on. Do it here. Okay, how to start this one? Equals yeah, how would you start this one?
What's in the brackets make it equal to A?
Yeah.
Cos yeah, so cos squared A equals minus 12.
Minus a half?
Yeah, minus
Oops.
half, sorry.
Oops. Better make that. I'll make it root 3 over 2. Oh, I don't know what I'm doing. I'll just make it a half. Okay, then.
Root both of them, so
Yep.
you get plus or minus root 2 over 2 equals cos A.
Equals, yeah.
Inverse cos of root 2 over 2 gives you 45. And 135.
Or cos A equals 135. And let's say I restricted the range from 0 to 180. So those are all my solutions.
Okay.
Sorry, that's A equals, isn't it? That's A equals. Okay. And then
so theta plus 60 equals that as well.
theta plus 60 is equal to that.
Yeah.
Actually, See, I'm really just throwing this together. We would have needed a range in the beginning. So let's say 0. Theta would be in between, let's say, those two.
Yeah.
And so that's theta, but we were solving theta plus 60.
So we need to minus 60.
Well, hang on. So what would the range be for theta?
Minus 60 and 120.
No. Theta plus 60.
Oh, sorry. So 60 and 240.
So 60 and 240, okay. And so are any of our answers not valid?
45.
So what can we do about that?
Add 360.
Be outside the range. That'll be for your third solution. How would you get second solution for cos?
360 minus 45.
Yeah. I think that's still not in the range though, is it?
No.
I don't want to mess around with it. I think maybe you do 360 minus 135. What is 360 minus 135?
225.
Okay, so you get 135 and 225. And so then how would you get theta?
Minus 60. Both those answers.
Yeah.
Okay.
That's it. And that would be your solution. 75. Whatever it is. 165 or something. Is that it? No, that's 185 or something. Well, I don't know. 60 it is. Yeah. How is that for you, Hugo?
Great. It's really good. Just one question. You know the one that we had that was 45.
Yeah.
If whatever you do, you can't get within the bound, would that ever happen?
I mean, for 45 we couldn't, but we could for the other one. Like, it's always the same process. Like, with the other one we could do, with both of them you do 360 minus. With both of them you could add or subtract 360. It's just that it's just the one on the right will give you the answer you need, and so that's why I kind of skipped to that.
Okay.
But it's like the quadratic one. If you just solve it fully, you know, you'll just get there anyway. We finished this chapter. Anything in particular you want for next time?
So we finished trigger, identities, and equations?
Yep.
Okay. Then, no, I don't know, I'll see you next week, but I don't know right now.
Okay. Yeah, well done, Hugo. You did great, and have a good week.
Great. Thank you. See you next week.
Take care. Goodbye.